You close control. Good morning, sir.
Good morning, sir.
Mute. Sir, good morning, sir.
Good morning.
Warm welcome to you, sir. Warm welcome to you. Very happy to see you for the National Workshop online, sir. We are waiting for VC sir's arrival, sir. Within a few minutes, we will start, sir.
Certainly. Okay.
5 minutes.
Thank you.
Yeah, within 5 minutes we will start, sir. Yeah, actually we are waiting, sir.
Okay.
ఇంకా మిగతా వాళ్ళు ఉన్నారమ్మా కేఎస్ఎన్
నల్లపరెడ్డి సార్ ఉన్నారు.
నల్లపరెడ్డి సార్ ఏది సార్కి విష్ చేస్తాం. ఓకే వీళ్ళని గుర్తుపెట్టుకో 5 మంది ప్రొఫెసర్ ఉన్నిచ్చు అంటే మనము
అక్కడ లాస్ట్ లో ఉన్నాడే ఆయన హుస్సేన్ అని ఎంఎస్ ఈ ఫస్ట్ సార్ కూడా
వచ్చానంత ఇట్లా అది నమస్తే అన్న రఘు అన్న
ఎవరినో
వీరే సార్
ఓకే చెప్పండి సార్ ఏముందిరా
ये वीडियो आता है तो आयशा आयशा वीडियो आता है तो म्यूट भी है नहीं वीडियो आता है तो
हाँ ये उनका लो तुम्हारा नहीं मैं बैठ को नहीं पे
वो हमें दिखता नहीं
नहीं म्यूट होता नहीं तो डरे म्यूट होता नहीं तो तीनों सीखें म्यूटिंग करना
Okay. To the distinguished guests, delegates, speakers, and all the participants of the National Workshop on Recent Trends in Geosciences 2023, a very warm welcome to you all. The Department of Geology is organizing a national workshop. So on behalf of the organizing committee, I welcome you all. I feel privileged to welcome the chief guest of today's function, Professor Ranga Janardhan Garu, in absentia, Honorable Vice Chancellor of Yogavamana University, Kadapa, Andhra Pradesh, to be part of today's national workshop on recent trends in geosciences 2023, organized by the Department of Geology, YVU, Kadapa. Thank you, sir, for accepting our invitation in absentia in your busy schedule. I feel glad to welcome our registrar, Professor YP Venkat Subbaya Garu, in absentia for this national workshop. It's immense pleasure to invite Professor K. Krishna Reddy Garu, Principal of Yogavamana University College and Dean School of Sciences, YVU, for today's national workshop. Thank you, sir. Now I request Dr. Siddhiraju to honor Professor K. Krishna Reddy Garu with a bouquet.
Love this. రాజుగారు రండి ఇట్లా ఏంది మరి ఎంత వయసు అయిపోయినా రాజుగారు ఇంకా థ్యాంక్ యూ అండి అందరికీ థ్యాంక్ యూ.
Thank you, sir.
మనకు రేపు సార్ నెక్స్ట్.
Thank you, sir, for accepting our invitation. I feel extremely glad to invite all the speakers of this national workshop, Professor S.M. Hussain Gar, Head Department of Geology, Madras University, Chennai. Can we see you? Yeah, sir. Very good morning to you, sir. Heartily welcome to the national workshop. We are very glad for accepting our invitation, sir. Thank you so much. Yes, sir. So now, may I request Dr. A. Nallapureddy Garu to switch on the video, please. Chief Scientist, ONGC, Chennai. Nara? Yes. Thank you, sir, for accepting our invitation and to be part of the national workshop. And I feel extremely glad to welcome Dr. Satyanarayana Reddy Garu, Head Department of Geology, Andhra University, Visakhapatnam. Sir, could you able to switch on your video? I think you are in the field work, as I guess. Yes. Thank you, sir. May I request Dr. V. Raghu Garu, scientist here, APSAC Space Application Center, Vijayawada, to switch on the video, sir. Sir, thank you so much for our invitation, for accepting our invitation and to be part of the national workshop, to accept our invitation to invited speaker. Yes, sir. Thank you, sir. Thank you. And may I request Dr. Srinivas Sharma, scientist, CSIR, NGRI, National Geophysical Research Institute, Hyderabad, Telangana. I think you are in a class, I guess. Thank you, sir, for accepting our invitation. And now we are very happy to have the gathering of the participants, not only from India, around the globe, Nigeria, Zimbabwe, Pakistan, Bolivia, and so on. A warm welcome to you all for this national workshop, and I hope you all have fruitful and scientific deliberations during all these 5 days. I, on behalf of the organizing committee, Department of Geology, welcome you all. Now it's time for invocation song.
కవితాత్విక నీకు వందనం చదువులం బ్రహ్మమనగా వేరే పరదేశమున లేదు, నీలోనే ఉంది చూడన్నావు తరచి. అంధవిశ్వాసాలు అణగదొక్కుడటల్చు గుణదోషములు మాకు ఓర్పుతో నేర్పి, ఆట వెలదిగ రసనపై నాట్యమాడితివి, పదిలంగ గుండెలు కొలువు దీరిన మౌని. యోగివే మన నీకు వందనం, విశ్వవిఖ్యాత కవి నీకు వందనం. యోగివే మన నీకు వందనం, విశ్వవిఖ్యాత కవి నీకు వందనం. క్రమశిక్షణతో మాకు చదువులెన్నో నేర్పి, కర్తవ్య దీక్షను మాలోన మేల్కొలిపి, ప్రజలందరికీ దివ్య ఫలితాలు అందించ మానవత్వపు దారిలో మమ్ము నడిపించి, భావి భారత శిఖర కిరణమై వెలగమని మా లక్ష్య పదములు విజయాలు కూర్చి, అమ్మ మనసున తీపి అమృతము కురిపింప, తేనియలు మా నోట ఒలికిల్చు మా తల్లి.
విద్యాలయం నీకు వందనం, విశ్వ ఆత్మబంధువు నీకు వందనం. విద్యాలయం నీకు వందనం, విశ్వ ఆత్మబంధువు నీకు వందనం. యోగివే మన నీకు వందనం, విశ్వ కవితాత్విక నీకు వందనం. విశ్వ కవితాత్విక నీకు వందనం, విశ్వ కవితాత్విక నీకు వందనం.
Thank you. May I now request Professor K. Raghubabu, Head Department of Geology, to have the opening remarks.
Thank you, madam. Good morning, all. Honorable Vice Chancellor Professor G. Rangajanardana Garu in absentia, respected Registrar Professor Y.P. Venkat Subbaya Garu in absentia, beloved Principal Professor K. Krishna Reddy Garu, my dear colleagues, Professor G. Surashan Raj Garu, Professor V. Sunita Garu, convener for today's workshop, Professor N. Jayaraj Garu, Dr. Srinivas Gaud Garu, other dignitaries, Professor Hussain Sir, the Head Department of Geology, Madras University, Professor K.S.N. Reddy Garu, Department of Geology, Andhra University, Visakhapatnam, Dr. V. Raghu Garu, Scientist, SF, Retired, Space Application Center, Andhra Pradesh, Professor Nalapareddy Garu, Chief Scientist, ONGC, Retired, Chennai, Dr. D. Srinivasa Sharma Garu, Scientist, CSIR, NGRI, Hyderabad, Telangana University, Telangana State. Non-teaching staff, research scholars, students, print and electronic media, a warm welcome to all. On behalf of the Department of Geology, I took privilege to introduce the department and about the workshop. The Department of Geology is one of the oldest department in this region, started in the year 1978-79 under the S12 Sri Venkateswara University PG Center, Kadapa. Later, in 2006, the PG Center is upgraded to Yogyama University and the department continued to serve with the motto of the university. The department is well equipped with conventional as well as advanced laboratories like geophysics, geochemistry, petrology, mineralogy, remote sensing, and GIS. The department proudly claims to have more than 80% of the students placed in several prestigious organizations like GSI, ONGC, AMD, CGWB, APSGWB, NRSC, APSSC, AP State Mines and Geology Department, as well as private organizations like mines industries in India and abroad. The present workshop, Recent Trends in Geosciences, is organized to explain the advancements in the geology sector. Now, I hand over the mic to Professor V. Sunita Garu, workshop convener, to tell about the workshop. Thank you, madam. Thank you.
Thank you, sir. Yeah. Coming about the workshop, this is about a national workshop, a 5-day national workshop from 27th February to 3rd March 2023. So on recent trends in geosciences. And this geosciences is an integral aspect of our culture and have historically provided various nations with both the financial and technological support. Natural resources and the capacity to process them are essential to contemporary society. Geoscientists' expertise is thus required for the handling of the novel and uncommon resources that might not be readily available. So these statements have received the right amount of the attention in the government and commercial business sectors thanks to geosciences education. Yet we must take into account that the classification of upcoming societal issues connected to the investigation and study of the earth sciences or geosciences needs to be resolved and put into practice right away. So the study of the geosciences is being divided in a variety of the pure and interdisciplinary areas of sciences like medical geology, and then environmental geology, climate change, land sustainability, and so on. And these have a significant impact on the society. These options enhance the possibilities of the societal necessities with our nation. So these options enhance the possibilities for the students and future generations to study the geosciences. And both men and women must now adhere to the higher education requirements to participate in the society and be able to tackle the real world issues. So basic education is necessary for this situation to contribute to the development and all-around abilities for surviving in an increasingly complicated society. For people to use the knowledge of the problem resolution, it is urgently important to encourage them to participate in the geosciences research environments within the society. So we, the Department of Geology, is organizing a national workshop on this, and we have 5 to 6 speakers, and the first speaker will be talking about his Professor S.M. Hussain Garu, Head Department of Geology, Madras University, Chennai. And the other speakers like Dr. Nallappa Reddy Garu, Chief Scientist, ONGC retired and is Chennai. And the Professor K.S. Reddy Garu, Head Department of Geology, Andhra University, Visakhapatnam. And Dr. V. Raghu Garu, Scientist, Space Application Center, Andhra Pradesh. And then Dr. Sri Srinivas Sharma Garu, Scientist, CSIR NGRI, Hyderabad, will be talking about the recent developments in the geosciences. And we have a huge gathering of the participants. I'm very glad to invite all the participants, students, research scholars, faculty from various disciplines like physics, chemistry, soil science, marine sciences, archaeology, agricultural microbiology, biochemistry, food technology, civil engineering, and so on. So we have a gathering not only from the India and around the globe like Nigeria, Zimbabwe, Pakistan, Bolivia, and so on. A warm welcome to you all for this national workshop, and I hope you all have a fruitful scientific deliberations during all these 5 days. And I, on behalf of the organizing committee, welcome you all. And a big welcome and thank you to IT team for their support to run this workshop online. And thanks to the PRO and the electronic media, Dr. Suresh and the other team for their support for the video coverage for this workshop. I thank you so much for all of you for having a wonderful gathering online, and I hope you will enjoy this workshop. Thank you. Now it's a time to introduction of a message by Professor K. Krishna Reddy Garu, Principal, YVU College, Kadapa, and also he is the Dean School of Sciences for Yoga University. May I request Professor K. Krishna Reddy Garu to have your valuable message on this occasion, sir, please.
Thank you, Professor Smita. Today, in Yogi Vemana University, we are conducting the online mode 5-day international workshop on recent trends in geosciences. The Department of Geology, headed by Professor Raghu Babu, and the senior faculty, Dr. Professor Sudarshan Raju, and Professor Sunita, Jairaj Garu, in absentia Dr. Srinivas Gaud Garu, academic consultant Siddhiraj Garu. And we are having the eminent speakers, Professor S.M. Hussain Garu from Department of Geology, Madras University, and Professor Nallappa Reddy Garu, very seasoned scientist, chief scientist of ONGC, retired, Chennai. And we are having another good speaker, Professor K.S.N. Reddy Garu, Department of Geology, Andhra University. And Dr. Srinivas Sharma Garu, scientist, CSR, NGRI. And this is really order of the day for us to go ahead with this kind of a research activity, because geosciences connects the biosphere, hydrosphere, atmosphere, and geosphere. These four spheres embedded the activity is the geosciences. So, as we know very well, biosphere is the connecting with the flora, fauna, and also we see the mammals and look for the available technologies for coping up with the increasing mankind, increasing the world population. So we have to look for the differently mutated food grains through biotechnology. And also, if you see in the other human sustainable activity, we need to understand the biosphere so effectively, and also very, very quantitatively we have to go ahead. We know very well hydrosphere, without water, there is no life for either human beings or for the mammals or for the trees. So this is the one of the very vital sphere where we have to study very effectively on the hydrological cycle, how the hydrological cycle in the global sense, how it is going ahead. If we are seeing the hydrological cycle, we know the rainfall is not very uniform in the spatially as well as temporally. So we have to have the through satellites and also ground-based observations. Given places, we have to take the through rain gauge network. We have to collect the rainfall information. These informations we can fed to the appropriate global models to see how this hydrological cycle is behaving for a given year or couple of years, for half a decade or 1 decade, we can see. And also we have to be very careful. We should not neglect the ocean. So we should not neglect the atmosphere, because the coupling between the land and atmosphere is vital activity. So without atmosphere, we cannot do anything. So it is the order of the day that we have to understand the atmosphere also, connecting the troposphere, stratosphere, mesosphere, ionosphere, hexosphere. So these, if we can study this coupling between the vertical coupling, horizontal coupling, and also global scale, and also the medium scale, mesoscale, and the local scale, hopefully we can connect the geoscience more effectively. So if you see the geosciences importance, we have to appreciate the oceans. So far, we are tapping the entire ground for getting the minerals and also coal for other explorations we are doing only through on the earth. But if you see the blue sea, it is the mother of everything, for not only for the hydrological cycle, but also for the biosphere activity, atmospheric activity, geospheric activity. If we can study the atmosphere, the ocean more effectively, that's feedback is very, very effective for the mankind, for the global sustainability. So nowadays, most of the countries are focused on the blue sea exploration. We can go deep into the ocean. We can study not only the sea surface temperatures, we can see what type of flora fauna inside is there, and how the coral reefs are there. If you see, and how these fisheries, how where it is hatching and how it is moving around, distribution within the given spaces. So that is also very, very important. So I am sure that the 5 eminent speakers are going to throw light on these aspects, and hoping that the participants across the globe may be more beneficial. They may trigger some of the good ideas for the coming research activities, and hoping that we may have the better life for the next generation we can give the better life and better activity, that is for the peaceful life for everyone who are going to live on this eternal world. I congratulate the Department of Geology and also Dr. Professor Sunita, the convener of the uh, recent trends in geosciences workshop, the 5-day workshop. So I wish a grand success, and also I congratulate the senior member, Professor Sudarshan Raju is my friend. So his inputs and insights into these recent trends in geoscience will be helpful. And we are having the two eminent scholars. One is Dr. Raghu Babu and also Dr. Jairaj. They are also very good, and hoping that they will bring the department into the next level. And we got the NAC A accreditation. These department will bring laurels to us to make it as a A plus, hoping for that. And they may increase the GR also for their department in the coming near future for the next academic year also. So with these few remarks, I stop here, and I sincerely thank the organizers for giving me this wonderful opportunity to share some of my very brief ideas with the august audience who are on the online mode. Thank you very much.
Thank you, sir, for your valuable insights on the workshop regarding how the marine and then atmospheric sciences will also play a major role. Thank you, sir, for your valuable message. Thank you so much. And before introducing the invited speaker, I should thank the Department of Geology, and I should thank the head Department of Geology and the other convener, Professor K. Raghubabu. Thank you, sir, for your valuable support. And I should thank Dr. G. Sudarshan Raju Garu, BOS of the Department of the Geology. Thank you so much, sir, for your contribution and valuable suggestions to make this workshop a grand success. And I should thank Jairaju Garu, eminent paleontologist, and to be the part of this national workshop. Thank you so much, sir, for your presence and for your suggestions and all this. And I should thank all the eminent speakers for the national workshop, all the 5 eminent speakers, and then Professor Krishna Reddy Garu also to be part of this national workshop. So name by name, I should thank each and everyone for making this workshop. And we have nearly around 470 people have registered. It's a huge gathering. I should thank all the participants, and I should thank the other delegates from the other thing to have participants of this program. So thank you, sir. And before going thus, we should have the introduction of the invited speaker, Professor S.M. Hussain Garu, Head Department of Geology, Madras University, by Professor G. Sudarshan Raju Garu, BOS of the Department of Geology.
Thank you, madam, for giving this nice opportunity for to read out the biodata of Professor Hussain. First of all, good morning, everybody. Respected the Vice Chancellor of Yoga Vemana University, FSC, Professor Ranga Janardhan Garu, and our beloved principal of Yoga Vemana University College, Professor Krishna Reddy Garu, and also our registrar, Venkat Subbaya Garu, in absentia. So, on my dear colleagues, first of all, I will read out the today's on the occasion of this 5-day national seminar. First of all, the speaker, the today's speaker, Professor Hussain Garu. Professor Hussain did MSc, MPhil, PhD from the University of Madras in 92, 87, 86, 86 MSc, 87 MPhil, and 92 PhD. Then he joined as a lecturer in the Department of Geology University. He has research experience in the field of environmental micropaleontology. He has done extensive research work on recent ostracoda of marine and marginal marine elements of Tamil Nadu coast, and also in finding out a signature possible paleo-tsunami deposits at the coast of Tamil Nadu and Andaman Islands. He has published 107 research papers, both in the national, international, and also he has completed 6 national funding research projects. Under his supervision, 20 PhD scholars are awarded their doctorate degrees, and presently 6 more scholars are working on different aspects of micropaleontology. So he has established 6 ostracoda new species, and they are described and incorporated in the International Ostracoda Catalog published by the American Museum of Natural History, America. Then he is a life fellow of Paleontological Society of India, Lucknow Geological Society of India, Bangalore. He has participated and presented papers in more than 80 seminars nationally and internationally. Also delivered not invited talks in few of them, also in the refresher course based in Singapore. He has visited Singapore, Malaysia, Thailand, Sri Lanka, and Dhaka to present his research finding in the international conference and participate in the overseas deliberations. So has also organized 25 national seminars, workshops, rank of convener, co-convener, organized secretary. So has received Dr. Sarvepalla Radhakrishna Professor and Research Award 22. He has served as Chairperson School of Earth and Atmospheric Science, University of Madras from 1729 to 21, and also serving as Chairperson Board of Studies Geology. Served as a Dean and Student Affairs, University of Madras from 22. Presently serving Director Research Scheme of Farm Projects, University of Madras from 22 to till date. So, thank you, Madam. Thank you for this nice opportunity for today's seminar. To read out the Professor Hussain biodata.
Thank you, sir, for introduction of speaker of Professor S.M. Hussain Garu. Thank you, sir, for your presence. And now you can share your PPT, Hussain Garu. I should also thank the other faculty, Dr. Srinivasa Gaud, sir. Though he is not available physically, he is able to connect through online. Thank you, sir. Yes. Sir, could you share your PPT? I think you can unmute. Hello? Yeah.
Pradap, is my slides are visible, madam?
The floor is yours, please.
No, the slides are visible.
Yes, sir.
Make it full screen, sir.
Yeah, make it full screen.
Full screen, sir.
Control M. Oh, yes.
I'm just sharing.
Okay.
అట్లాంటి కవర్లో పెట్టి అట్లాంటి దీంట్లో రేపట్లో
Sir, you may talk up to 1 hour. That means up to 12:15 or so, 12 to 12:15, and then we can have the interaction. And the participants, if you have any doubts, please ask Professor Hussain Garu after the talk. And if you have any doubts, please insert in the chat box.
లైఫ్ సైన్స్ ఒకటి ఫిజికల్ సైన్స్ 8 ఉంది కదా లిస్ట్ ఉందా లేదా లేదు అనుకున్నా రీసెర్చ్ చెప్పి ఇది దీంట్లో ఇది ఆర్ట్స్ అండ్ హ్యూమానిటీస్ రామ్ ప్రసాద్ రెడ్డికి 2 పాపాలు
వీడియో ఆఫ్ చేస్తా
ఫిజికల్ సైన్స్ ఇంజనీరింగ్ బుక్.
నేను మన సిద్ధిరాజు పేరు
మేడం హలో
హలో sir,
you are able
it's
to see my
visible,
slides?
sir. Yes sir, we could see, but could you make it the full screen? Yeah, slides are visible, sir. Could you make the slides full screen?
Okay, okay, now it is okay.
Yeah, it is okay. No.
Okay,
How to?
okay madam, slides are moving.
కదా
No sir.
బిట్టు చంపుతావు. అవును
Slides are moving.
No sir, not yet.
నీకు అన్ని నేను చేసిస్తే కూడా చేసేదాంట్లో తొందరగా వస్తున్నా నాకేం అవసరం పడలేదు పడితే పర్లేదు.
ఫుల్ చేసుకోమని చెప్పాలా సార్? ఆప్షన్ ఉంటుంది.
బిస్కెట్ బిస్కెట్ తీసుకో.
ఫుల్ స్క్రీన్.
Okay. Stop and go. Okay. ఇదేనా? ఇదేనా? You just confirm me whether the slides are moving or not. Madam?
Sir, you can make it full screen. Can you?
I have made it.
No.
No, sir, we can't see, sir. We can't see full screen, sir.
See only the overall.
And they are not moving, sir.
దానికోసమనే
షేర్ ఆప్షన్ మనం చేసాం.
Okay.
ఇప్పుడు మూవ్ అయింది.
Yeah,
Yes, sir. Moving, sir, but not full screen.
Now I have made it full screen.
But we can't see, sir.
No, sir, we could not see.
Shall I put it in this mode itself and continue my presentation?
Yes, sir. Please, sir. Please, you can continue, sir.
Now the slides are moving.
Yes, yes, sir.
Yes, sir. Yes, sir.
Moving.
Go ahead.
Shall I continue like this in this mode?
Yes, yes, sir. Yes, sir. They are visible, sir. You can continue, sir.
Okay, no problem, no?
Yes, yes, sir. Yes, sir.
Sir, could you press F5?
Function key.
Function key F5, sir. It's just a request. Could you press F5?
నొక్కి చూపు ఫంక్షన్ కి పిలిస్తే
Okay. Is it in, please confirm, is it in full screen?
No.
Sir, it is okay, sir. Not in full screen, but it is visible, sir.
distribution of
Shall I go ahead?
Yes, yes, sir. Yes, sir. Please, sir.
But I should get the confirmation that the slides are moving or not.
Slides, you are
Previously,
making them the motion.
they were moving. Now the same
I
situation.
put F5 only, F5 only.
asked for all.
Okay.
But in general,
But we couldn't.
why geoscience? What is geoscience?
They are not moving, sir,
Human society.
but visible.
Now,
ఏం చేసాం
No, not moving, sir. Ah, yes, sir. Yes, sir.
Now
They
it's
are moving.
ఏం
Okay, sir. Please continue.
Go ahead, sir.
okay.
Past, present, future.
In the full screen mode, you are not able to see this movement of the slides.
Okay, sir. No problem, sir. Please go ahead, sir. They are okay, sir.
Okay, okay. In that case, I will proceed.
Please, sir. Please, sir.
Okay, sir.
Okay, okay. Yeah. So, a very good morning to all of you. Most honorable Vice Chancellor and respected Registrar who are attending this national workshop in absence. I mean, they're not physically attending now because of their busy schedule. And the principal, Professor Krishna Reddy Garu, the head of department, Professor Raghubabu, senior Professor Sudarshan Raju, the convener of this workshop, Professor Sunita Madam, and other senior professor, Professor Jayaraju Garu, and the enthusiastic participants. I mean, Dr. N. Reddy Garu is also there, and my well-wisher. And very enthusiastic dear participants, a very good morning to all of you once again. At the outset, I profusely thank the organizers for having given me this opportunity to just share a few things about my expertise, that is about fossils in general, and Astropoda and their couple of applications in particular. And if you have any doubts at the end or in between also, you can interrupt me and then ask questions. And so this is the title of my presentation, Distribution of Astropoda and their Statistical Aspects, their implications on paleo-environment and high-energy marine events and the respective sediments. So this is the title of, I mean, this is the outline of my presentation. And this is the outline of my presentation about our Earth and certain important landmarks, significant landmarks, and then introduction on microfossils, and then astropods and their ecological aspects, and then the third component is the tsunami and the identification of tsunami deposits through the distribution of astropoda. A brief, a couple of case histories from Andamans and Tamil Nadu. We know that our Mother Earth is originated about 4,500 million years ago it has been determined or established by the age by C.C. Patterson through uranium-lead isotope dating, specifically lead and lead dating. And for the benefit of non-geology participants, there are few important landmarks that have taken place after the origin of the Earth, 4,600 million years onwards till date. Some significant landmarks of the Earth I just would like to put before you, particularly for the benefit of the non-geology participants. So 4,600 million years is the formation of the Earth, Moon, and other planets. The Earth magnetic field is also formed during this period. 3,500 million years ago, the first permanent crust. Prior to that, it was not. It was very liquid or semi-liquid state, and then permanent crust has been formed. And then 3,500 million years ago, the Earth's atmosphere has formed with more amount of carbon dioxide, and also the seawater is also formed simultaneously during the same time. And 3,300 million years to 2,500 million years ago, the oldest sedimentary rocks, they are formed. And even though the Earth is originated about 4,600 million years ago, but the life on the Earth is appeared approximately about 2,500 to 3,000 million years ago. Only from that period onwards, the life has started appearing on the Earth, because prior to that period, there was no sufficient amount of oxygen in the Earth's atmosphere. So this period is known as, that is 3,000 million years or 2,500 million years, is considered as the period of oxygen revolution in the history of the Earth. Because of the presence of oxygen, sufficient amount of oxygen only, the life has appeared initially in the form of prokaryotic organisms like algae, fungi, bacteria, virus, etc. And afterwards only you start getting the eukaryotic organisms. So that is the life appeared. Okay, and then 2,000 million years onwards, first large-scale glaciation on the Earth. Then 2,000 to 1,000 million years ago, rapid growth of continents by the accretion of the microcontinent. Actually, these Pangea we know. Prior to that also, we were having 3 other single land masses, huge land masses, single continent was there. Rodinia, Ur, like that. So then after that, 7,700 to 600 million years ago, major glaciation affecting every continent. And then the 550 million years, this is the actual period, 550 or 570 million years is considered as the appearance of the eukaryotic organisms. Initially, you have got the invertebrates like your brachiopoda, pelecypoda, gastropoda, cephalopoda, echinodermata, coelenterata, etc. And of course, after this, amphibians, I mean fishes also appeared, and fishes, amphibians, then reptiles, aves means birds. Then you have the mammals. So that is the appearance of the vertebrate organisms. Then 250 million years ago, there was a mass extinction in the marine environment. And 270 million years, the supercontinent, that was the latest known supercontinent. Prior to that, there were other 3 supercontinents were there, but this is the supercontinent. It is very much justified by putting all these different continents which we have, put them together. They fit each other comfortably, and we will come to know about the existence of Pangea in the geological past. And this Pangea got departed into Gondwana land and Laurasia. That thing has happened. And then 250 million years ago, the dinosaurs appeared, and they were dominant during the 2010 and 145 million years ago. That period is called as Jurassic time. Jurassic time, they were dominant. But at the end of the Cretaceous, all these dinosaurs, they became extinct. So this is the thing. 65 million years, that is the end of the Cretaceous. During this time only, the huge mass extinction, the major mass extinction. There were 5 major mass extinctions that have taken place. This is the latest one, major mass extinction at the end of the Cretaceous and the beginning of the Paleocene. So major mass extinction has taken place. During this time only the dinosaurs on the land, they disappeared, they wiped out, they became extinct. And then the marine forms, ammonites, they became extinct. So like that it has happened. Then 50 million years ago, the grasses, they emerged on the land. Because of this only, the grazing animals like horses and then elephants, they were dominant. And 30 million years ago, the Japanese island, it split from Asia, opening up of the Japanese Sea. And then as far as the orogenic activity is concerned, 20 to 15 million years, the Alpine orogeny, Alps have formed. And then 20 million years ago, India began to collide with Asia, initiating the beginning of mightiest and youngest mountain chains. And we all know that the Earth has got several plates, among which 7 major plates are there, like your North American plate and South American plate, Eurasian plate, and Antarctic plate, African plate, Indo-Australian plate. So like that, these are all the 7 major plates are there. In addition to that, 7 major plates and 15 micro plates are there. These plates are in continuous motion and they are moving at different velocity. As far as India is concerned, Indian subcontinent, this plate is moving in northeasterly direction at a velocity of 5 centimeter approximately per annum and hitting the Himalayas. Then 3 million year Antarctica, it got isolated, and then 2 million years ago, the major isolation, the Pleistocene glaciation, and 1 million year that Homo erectus, and the last glaciation is the LGM, last glacial maxima, 18,000 years ago, it has taken place. So this is the in brief, which I have just explained you, the significant geo landmarks, the important landmarks. 4,600 million years and up to 2,500 million years, there was no life. That period is called as Azoic. And after that, 2,500 to 570, it is Proterozoic. Here you have got the prokaryotic organisms like algae. So these Proterozoic eon, generally the time scale of Earth is divided into major period called eon, and it is further divided into small units called eras, and they are further divided into periods, and then further division is epoch. So this Precambrian eon, we have 2 units. One is Archean eon and Proterozoic eon. And then after that, from 570 million years onwards, still present, it is called as Phanerozoic eon. So during this Proterozoic eon only, as I told you, you have got the prokaryotic organisms. They are being represented in the form of algae and other thing, and the Kadapas, Windians, Carnules, and then they're all belonging to the Proterozoic age. And that is why during these Kadapas, you can get the algal stromatolites. Stromatolites are seen. So in Paleozoic, we have got the trilobites, fishes, brachiopods, all other forms are there. But during the Carboniferous time, we have got the abundant vegetation. And this vegetation is the main reason for the present day Gondwana clay and Gondwana coal deposits. These are all the main things. And at the end of the Permian, you have got the formation of this particular Pangea, and late Permian, it started departing and disarticulating the Pangea. Then as far as the mountain orogenic activity is concerned, the Appalachian mountain activity is taken place in the Paleozoic itself, end of the Paleozoic. Then the Sierra Nevada mountain activity in the Mesozoic time, and the Rocky Mountain activity also at the end of the Mesozoic. And then, as I already told you, the extinction of the dinosaurs at the end of the Cretaceous and the beginning of the Paleocene. And then Alpine orogeny and the Himalayan orogeny in the tertiary, it has ended up. And still the orogenic activity is still going on. And we do have the Ice Age, and then this is the thing, the mammals, they appear. So this is in brief for the benefit of the non-geology participants. And as far as geology is concerned, it is a very important basic sciences It is one of the very important basic sciences. One of the important basic sciences, in addition to, along with physics, chemistry, biology, botany, and zoology. And this particular subject has got direct link with the mankind, humankind. So that is why geology, I mean, as far as the mineral resources are concerned, like metalliferous, non-metalliferous, fossil fuel deposits, and also various geohazards, the earthquakes, floods, the tsunamis, avalanches, landslides, all these things are being dealt with the knowledge of the geology only. So unless and otherwise you have sufficient amount of geological knowledge, the metalliferous resources cannot be found out. Recently also, Geological Survey of India, they have encountered a huge deposit of lithium in Jammu Kashmir area. So also, and these days, I mean, many earthquakes are being happening. Where it is occurring, what intensity it is occurring, it cannot be prevented. Of course, the earthquakes and other things, they cannot be prevented, but they can be predicted to some extent. And then we can give the alarm, we can give the signals to the concerned governments so as to mitigate the life loss and property loss. So geology is very vital subject. So we need to introduce in school levels and then study it and train the humankind so that they will be alert during any kind of these geohazards, and they can save themselves and the property also, they can be to some extent we can save. So like that, these things happens. As far as geology is concerned, we have got huge opportunities, geological opportunities, job opportunities are there. To mention few, Geological Survey of India. Here you can, by writing the UPSC exam, Union Public Service Commission exam, you can go as a geologist and as a hydrogeologist also in Central Groundwater, CGWB, Groundwater Board. And then National Thermal Power Corporation, National Hydropower Corporation, and these are all the some of the national and state governmental agencies where the geologists are being employed. So for your information, I'm just putting some of the important organizations where a geologist can be recruited. Indian Space Research Organization, Space Application Center, National Geophysical Research Institute, it's located in Hyderabad. So here many geologists, geophysicists, geochemists are working here, and they are doing a yeoman service to the country. And then Atomic Mineral Division, AMD, and there is a, I mean, once these fossil fuels are exhausted, the fossil fuel resources are exhausted, then we have to find out for an alternative energy. The future alternative energy will be either gas hydrates, that methane gas molecules which are entrapped in the oceanic beds. But of course, that technology of exploring the gas hydrates is not yet fully studied, fully established. But the atomic energy is there. That will be the future alternative energy. So atomic energy, atomic mineral identification is done through AMD, Atomic Mineral Division. Then we have ONGC, Oil and Natural Gas Corporation Limited, and Oil India Limited, like that it is there. And so what I mean to say is geology is one subject where the role of a geologist, the key role that is being played by geologists in different organizations, which is directly related to the humankind. Okay. And then National Institute of Oceanography, NIO, Goa, where you have the Geological Oceanography Division. And they do a lot of work in the oceanic environment. They identify a lot of polymetallic nodules and other things. So NIOT, National Institute of Ocean Technology in Chennai, they are working on gas hydrate, the exploring, the identification of gas hydrate resources. Bharat Petroleum Corporation Limited, Hydropower Corporation Limited, Indian Oil, etc. So a lot of scope is there for a geologist, but only thing is the needed awareness, needed publicity is not given for geology subject. That is why some of the students are not being known about geology and they are not being attracted towards geology. Then to continue with the job opportunities, we have Oil India Limited, not only the state and central governments, but also some other private agencies also recruit, like your Reliance, Oil and Gas, Shell India, Slumberger. So these are all the other private things where the geologists are being employed. And Naiveli Lignite Corporation in Tamil Nadu, that is there. GAIL India Limited, K Energy, Coal India Limited, Central Groundwater Board. So these are all the some of the state and central government agencies where geologists are being employed. Then come to our subject part. Then, as I told you, there are 5 major mass extinctions that have taken place in the history of the Earth during the Ordovician Silurian time, and this is the period 445 million years ago when it has occurred, and this is the percentage of the life that disappeared. Similarly, during Devonian Carboniferous time, 375 to 380 million years of 60% of the life disappeared. And if you see all these major mass extinction, volcanism is the major cause. That is the main cause for the extinction of the life. And recently, I mean, this is the Permian, Triassic, Jurassic. These are also other major mass extinctions. In addition to these, minor mass extinctions are also taken place. Several minor mass extinctions are also taken place. So KTB, Cretaceous Tertiary boundary, that is Cretaceous Paleocene mass extinction. And here the asteroid impact is another cause. Some people, that is also another concept, but the Deccan basalt, Deccan volcanism is the main culprit. In addition to that, asteroid impact is also there. So generally, to mass extinctions for Cretaceous Tertiary, we should say CTB. But why we are saying KTB is already during the Cretaceous time, there is a minor mass extinction. Cenomanian Turonian time, there was a minor mass extinction. But in order to avoid the duplication of the term, we are using the term KTB. K is Crede, the German word for Cretaceous. The T is tertiary, KTB, Cretaceous Tertiary boundary. Otherwise, it should have been CTB. The bolide impact, the proof evidence is Chicxulub in Mexican province. There is a crater, and because of this asteroid impact, the dinosaurs became extinct. That is one concept. Other concepts are the recently Gerta Keller and of course Gerta Keller, Dr. Ian Reddy, and then Professor Dr. Jayaprakash. They all worked together and they have given a conclusive evidences for the extinction of the dinosaurs through the volcanism, that is Deccan basalt volcanism. So these are all the things. Then come to the other introductory part. As I already told you, the life appeared on the earth 2,500 million years ago, and that past life is being studied through fossils. That is called as paleontology. Paleo means ancient, ontos means life, logos means science. Science of ancient life, it is being studied through fossils. Unless and otherwise you have fossils, you do not know about the past life, like dinosaur or whatever it may be. So if fossils are not there, we would not have come to know about existence of the past life. Then the present life is known as neontology. Neo means existing or now. Ontos means life. Logos means science. Science of existing life. What are the plants, animals, and the microbes we see, that all come under neontology. Whatever we could not see and what existed in the geological past, that comes under paleontology. Through fossils we study. And we have the paleo, past animal life and past plant life. Paleobotany is known as past plant life, which we call it as flora, and past animal life, which we call it as fauna, and paleofauna, like your invertebrate, vertebrates. As I already told you, invertebrates, Pelispoda, Brachiopoda, Cephalopoda, Gastropoda, Coelenterata, Echinodermata. So all these are there. Vertebrates, you have the amphibians, fishes, reptiles, aves, mammals, etc. And in addition to that, there is another important life that is called as micropaleontology. Micropaleontology is nothing but a fossil which is very tiny in size, whose morphological characters cannot be studied best with your naked eye. Why? Because their size is in millimeter and some are in micron size. And you need to have a stereo binocular microscope for their study. So that is called as micropaleontology. So micropaleontology plays a very vital role when compared to megafossils because of their minute size, ubiquitous presence, wide geographical distribution, very sensitive to the environmental conditions because of the availability of many catalogs. So micropaleontology is very, very vital in unraveling the paleo-environmental things, and also to identify the various fossil fuel deposits, and also to study various sedimentary basins. So these microfossils of different kinds, different groups, like organic world, mineral world, and organic world means, as the name implies, they are derived from the plant remains, like spores, pollen grains, secretars, and chitinosols. Mineral world, of course, they are made up of with some mineral content, mineral matter, like your calcium carbonate, calcareous, silica content, siliceous, and apoptotic part that is phosphatic. And we have different microfossils like foraminifera, osteopoda. They are all calcareous, radiolaria diatoms. They are all siliceous, and conodonts are the phosphatic. So these are all the organic world group of microfossils, spores, and pollen grains. And this is a planktonic, this is a benthic foraminifera bolivina, a cluster of the and this is a planktonic foraminifera. Planktons are the one which live in the water column. They are the pelagic organisms. And this is Arbulina universa, live form. You can see the flagella, and you can see the life. And as far as the micropaleontology is concerned, the essential thing is microscope. It is being invented by Otto Leeuwenhoek in the year 1660. After that only it has gained its momentum. And then during Second World War, the great demand for the petroleum. That is why many oil industries, they have started establishing the micropaleontological laboratory, and the micropaleontological research work has gained its momentum. Then the Carl Linnaeus binomial nomenclature also, it has been given a lot of this thing, so as to avoid the ambiguity in the etymology, that is naming of the species, overlapping of the species names, and a lot of confusions, errors are being removed. And then, as I already told you, because of these properties only, the microfossils are so important when compared to the megafossils. For example, if you take a small quantity of sediment sample, sandstone or limestone or whatever it may be, of 50 grams or 100 grams, you will get hundreds of microfossils. Whereas in case of a megafossils, you have to walk around several meters and kilometers to encounter a megafossil. So that is the advantage of microfossils. And then this particular figure shows you the geological distribution of these microfossils. Calcareous, algae, osteopoda, foraminifera, bryozoa, they are found to occur in the entire Phanerozoic eon. Whereas the siliceous forms like your diatoms, silicoflagellates, and they appear at the late Jurassic or early Cretaceous to recent. And whereas when you see the phosphatic forms, they first appeared in the Cambrian and disappeared by the end of the Triassic. So like that, they have got their own geological distribution. The age is there. Some of the forms are very good index fossils. With the help of the good index fossils, we establish the biozones, and the age implications can be studied. Age of the strata can be found out. Okay. Then this is a stereo binocular microscope on the left-hand side, through which foraminifera, osteopoda are being studied. On the right-hand side, you have the modern polarized light microscope, through which the organic world, that is some of the spores and pollen grains, diatoms, silicoflagellates, dinoflagellates, nanoplankton, these are all in micron size. They can be studied with the help of this particular microscope. And scanning electron microscope. Of course, this is very, after the advent of the scanning electron microscope, through the studies of the ultrastructure of these microscopes, most of the taxonomical ambiguity, repetition of these names of the species are being avoided, and it has given a lot of information on that. Then come to Yeah, these microfossils, some are preferably occur in some kind of a sediment type. Say, for example, if you see osteopods, they are found to occur in sandstones, and then limestones, etc. Whereas when you study the diatoms, they are the siliceous forms. They will be occurring in only in the siliceous type of sediment only. Whereas when you see the spores and pollen grains, they are the organic world. They occur more in the large circle is more abundant occurring. The smaller circle is rare occurrence, and the empty circle, this not black colored circle is sporadic occurrence. So spores and pollen grains, they occur more in, they are the organic world, the organic, they occur more in coal and lignite fossil, and also in the marls and clays and shales like that, limestones. So like that, that depends upon the type of the microfossil we are studying. Accordingly, only you have to select the sediment type. Suppose if you are studying the spores and pollen grains, if you concentrate on the siliceous sediments, then you will very rarely you will get. But if you concentrate on the organic coal and lignite and other things, then you will get good number of microfossils. So depending upon the type of this microfossil, accordingly you have to select the type of the sediment. Then osteopoda, they belong to phylum Arthropoda, class Crustacea. When the osteopods are generally characterized by the presence of two valves, these two valves are intact, that is called as carapace. Then when it gets detached, both the valves, sometimes they get detached, we call them as open valve. So their size is 0.5 to 1 millimeter. Some Paleozoic forms, they attain a bigger size, up to 30 centimeter, 30 millimeter. So that size is there. But otherwise, their general size is 0.5 to 1 millimeter. The geological range in time is Ordovician to recent. And as far as their habitat is concerned, osteropods, they are found to occur in all kinds of aquatic environment, starting from freshwater lakes, ponds, pools, rivers, and brackish water, estuaries, lagoons, backwaters, mangrove environment, and also in the marine environment, shallow marine to deep marine environment. So, as far as the habit of osteropods is concerned, the mode of living, they are mostly benthic forms. Some are sessile and some are vagrant, and few infaunal, few epifaunal, but rarely you get pelagic forms. Among the pelagic type, you have, as I already told you, planktons and nectons. But these forms, they have got the appendages. With the help of the appendages, they are able to swim in the water column. That is why they are called the nectons. Even though they live in the water column, they are with the help of their own locomotory organ in the form of appendages, they are able to swim in the water column. They are the nectons, like your podocopids. Podocopids, example, polycope. They are all the nectonic forms. So this is a figure that shows you the habitat of the osteropods distribution. See, this is the river, and where it meets the sea, it is an estuary, and you have got the lagoon here, and the shallow marine to deep marine, shelfal to slope environment, up to deep also, they are found to occur. Not only that, in the forest, humid soils, and in the rice fields, and some of the osteropods are being reported from the intestine of fishes also. So such is the varied distribution and occurrence of osteropods. So that is an advantage over the foraminifera. Foraminifera are exclusively marine, but of course, a few occur in brackish water, but you don't have freshwater foraminifera. So osteropods, as they grow from childhood to the adulthood, they sheds out the external shell and attains a new shell and reaches the adult stage. There are about 8 growth stages will be there, and ninth one will be the adult form. That is called as molting or ecdysis. Why I am telling this is, in a pristine environment you are supposed to get all the growth stages, but whereas in a polluted or some kind of environmentally disturbed environment, you don't get all the growth stages. One or two growth stages will be missing, and even though they are very small in size, 0.5 to 1 millimeter, the sexual dimorphism is observed in osteropods. Males are there, females are there. Then come to ecological aspects of osteropods. For that matter, every organism, all kinds of organisms, whether it is a plant, flora or fauna, or even humankind, all are being controlled by certain ecological parameters. And those ecological parameters are being classified as physical, chemical, and biological parameters. So the physical parameters, like suppose if it is an aquatic environment, then you have to see what kind of substrate, what is the water depth, what is the current action, and all these things. And the chemical parameters like dissolved oxygen and the calcium carbonate content and all those parameters. Biological parameters like the amount of the food that is available for the organisms to survive, and also the predation. Predation is another biological parameter. So let us see one after another. The first one is temperature of the environment where astropods are being controlled. So you have the equator, and 20 degrees south or 20 degree north, you have the tropical environment. In the tropical environment, tropical astropods are found. Then if you move further north or south, you have got the temperate environment. The temperate astropods are being recorded. Further south, extreme south, further extreme north, you have the polar region, cold water. So there also you have got the cold water astropods are found. So the temperature is one important factor controlling the distribution of astropods. The cold water forms are called psychrophilic, and shallow water forms are called, or marine forms called thermophilic. There is one genus known as Heterocypris. It has got the ability to withstand a temperature of 50 degrees centigrade. So by studying the stable isotope of osteopod carapace, we can find out the paleosalinity and paleotemperature. And salinity is, of course, salinity and temperature. If temperature is more, the salinity is also more. And as temperature is low, the salinity also low. During the rainy season, what will happen? More freshwater influx will be there, and the salinity content reduces. But during the summer time, more evaporation takes place and the salinity content increases. So like that, so you have the freshwater osteopods, so brackish water osteopods. This division is mainly based upon the salinity content of the water. So salinity content in freshwater is low, 0 to 0.5 parts per thousand, and these brackish water forms 2 to 10 parts per thousand PSU. So these are all the brackish water forms, oligohaline, mesohaline, like that. But whereas when you come to the marine environment, there the salinity content will be more than 32 parts per thousand, and here also you have got the osteopods. And sometimes, in salt pans, the salinity goes up to 70 parts per thousand, 80 parts per thousand. There also some super saline osteopods are also being reported. So this is when both the valves, when carapace is detached or opened, this is the internal view here, where you can see these osteopods. They look like externally pelecypods, lamellibranchs, but they're internally, if you see, they will have appendages. Based upon the soft parts and other things, they are being classified into phylum Arthropoda, class Crustacea. But the external appearance, they resemble to pelecypoda. Externally, they look like pelecypods. So this is an internal morphological character. You have the hinge and other parameters. And this is the external SEM photographs of few osteopods where you can see the ornamental features. And the hinge also important. As I told you, both the valves get detached themselves by means of hinge structure. Hinge also three types. One is adont or very simple hinge. Other one is merodont, a kind of a medium one. And entomodont or amphidont or heterodont is well evolved advanced hinge type. Generally, this adont hinge can be seen in freshwater forms and deep marine forms where there won't be that much turbulence of the water. So simple hinge, they get attached. Whereas amphidont or heterodont hinge osteopods are attached firmly because of the turbulence and the current underwater current agitation. They are firmly attached. So just by studying the hinge structure itself, we can say that what kind of sediments in which these fossils are, my osteopods are deposited. So we need not go for the identification of the species, osteopod species. Generally, our students are afraid of naming the species, osteopod or foraminifera or any kind of fossil naming, they are afraid. But here, in case of osteopods, I just tell you that you don't bother about the naming of the species, name of the species. Just study the hinge structure alone, you can tell whether it was a freshwater environment, or the sediments got deposited in a brackish water environment, or the sediments got deposited in a shallow environment, shallow marine environment, or a deep marine environment. Like that, you can identify basic identification. Initial baseline data can be obtained. So this is the salinity and depth characteristics. I'm not going into the details. And this is the marine shallow water forms and deep water forms. As I already told you, deep water forms, they occur more than 1,000 meters of water depth. And that as you go deeper and deeper, the temperature reduces 4 to 6 degrees centigrade. Those are called as psychrospheric forms. And example, Agrinocyteres, Posidonamicus, etc. Whereas shallow marine forms, they will have this type of thick amphidont hinge, strong ornamentation like that. So these are all the characteristics. Differentiation between the deep water forms and the shallow marine forms. And the substrate also, as I told you, substrate is a physical parameter, and you have the silty, clayey substrate, muddy substrate, sandy substrate. Accordingly, the assemblage varies. Fine grain substrate, a kind of non-spinose, non-ornamented forms will exist there. Whereas when you go to a sandy or coarse-grained substrate, then there you will get the little bit ornamented forms will be available more like that. Then the next parameter is predation. The predation is nothing but a higher organism comes and attacks the lower organisms and eats away. So in case of Osteopoda, the gastropods, two groups are there. One is Muricid group, other one is Naticid group. These forms, they come and attacks the osteopods just by drilling the hole, eats away the soft parts, and thereby the predation is a negative parameter which controls the population abundance and distribution. And we can find out by observing the Muricid predation and Naticid predation what kind of environment it was. In the case of Muricid predation, the hole that is being made by the gastropods is oblique hole, and the shape of the hole is it is irregular. Whereas in case of Naticid environment, the hole is vertical hole on the carapace, and the shape will be circular or semicircular. So this is seen in the shallow marine environment, but this is seen in the deep marine environment. Like that, we can find out, we can differentiate. Then come to some important statistical aspects of osteopods, which will be helpful in identifying the petroliferous content of the sedimentary horizons. So carapace valve ratio, these are all some of the parameters. Let us see one after another. Generally, in a pristine environment, in an oxic environment, the color of the osteopod carapace will be pale yellow, light colored, and the light colored specimens. Whereas when the environment is suboxic or anoxic, the color of the osteopoda carapace turns into dark green, gray, black, brown, even red color. So by identifying the coloration of the osteopod carapace, we can find out whether we can differentiate whether it is an oxic environment, suboxic environment, or anoxic environment. Generally, anoxic environment is very much needed for the preservation of the for the generation of the hydrocarbons. How hydrocarbons are generated in a sedimentary horizon or a sedimentary basin is when you have the sedimentary, the sediments are there, and the aquatic environment, whether it may be an inner shelf or a deep marine or a deltoic environment or an eritic or whatever the environment may be, during that time you have the abundant osteopoda or abundant group of organisms, microorganisms. These organisms will have more amount of organic matter. After their death, this organisms, they go and settle down in the sediments and get deposited. Suppose if that particular environment is an oxic environment, whatever the organic matter that is seen in the dead organism, it gets decomposed. Decomposition takes place. Suppose if it is a anoxic environment, whatever the organic matter that is seen in the dead organisms, it will be preserved in the anoxic environment. That preservation of the organic matter in due course of time, because of the subsequent deposition and other thing, and because of certain temperature and pressure actions, that organic matter converts into kerosene initially. That kerosene later on it converts into either liquid form of hydrocarbons or gaseous form of hydrocarbons, depending upon the subsurface subsurface basinal temperature. So generally, for the thermal maturation of this organic matter or for the generation of the hydrocarbons into liquid, oil, or gaseous, the temperature range is 100 to 300 degrees centigrade. And at lower temperatures, you will get liquid form. As the temperature, subsurface temperature of the basin or the subsurface sediments increases, you get the gaseous forms. If the temperature of the basin increases beyond 300 degrees centigrade, then you get the carbon dioxide generation takes place, which escapes through the fissures, joints, cracks, and other things, which is of no use for us. Then the carapace and valve ratio. So as I already told you, when both the valves are attached, it is called as carapace. When they get detached, it is called open valves. See, the dead organism, Osteopoda, after its death, it goes and settles in the basin, in the sediments. And after the subsequent burial, subsequent deposition of the sediments, if it is an immediate burial, if it is a faster rate of sedimentation, immediate burial takes place and the osteopod carapace will be preserved as such, intact. If the sedimentation is slow, at a slow rate of sedimentation, what will happen? The dead organism is supposed to get exposed to the current action, wave action, and other bacterial action and other thing. They get detached, they get separated out, and under those circumstances, you get more of open valves. So, rare, slow rate of sedimentation is directly correlated to the more of open valves. The faster rate of sedimentation you can directly relate to occurrence of more of closed carapaces. So this ratio is very much helpful in order to find out a relative rate of sedimentation in a sedimentary basin. This particular parameter has been used by several researchers. For example, Mackenzie and Guha, DK Guha from ONGC. He has observed a rapid rate of sedimentation in Eocene, Oligocene basins of Australia and India. So also Ahmad et al. They observed in 1991 a high rate of sedimentation in the upper Eocene and the lower Miocene deposits of Lindi area, Tanzania. And then Guha again, when he was working in ONGC, he studied this particular parameter from the Kutch Basin, and also he has observed 100% of closed carapaces, and which directly relates to a relative rapid rate of sedimentation in the Eocene sediments of Cambay Basin. And also he studied the Kutch Basin, Miocene sediments of Kutch Basin, where he has observed only 80% of the closed carapaces, which he deduced or inferred a relatively slow rate of sedimentation. So like that, we can directly take that parameter into consideration and we can give the relative rate of sedimentation. Degree of pyritization. Generally, pyrite crystals are formed in a reduced environment, that is in an anoxic environment. These pyrite crystals which are formed in an anoxic environment, sometimes they get agglutinated over the osteopod carapace. So by studying the agglutinated or adhered osteopod carapaces, we can infer whether it is a oxic or suboxic or anoxic environment. So also the current index. As I told you, you have the juveniles and the adults. The ratio of juvenile and adult ratio gives you an information on the current index of the environment. Say, for example, higher value of current index is seen in the littoral environment, whereas low current index is seen in lagoonal assemblage. Generally, in the lagoonal assemblage, there won't be much current action. Because of that, whatever the dead organisms which are preserved in the sediments, the organic matter will be preserved more. So that organic matter, chances of converting into kerosene is more. Whereas in the littoral environment, because of the current action and other thing, whatever the organisms, the microorganisms which are dead organisms which are deposited, they are being transported by the action of the currents, and it is not much congenial environment. Littoral environment is not much congenial environment for the generation of the hydrocarbons when compared to lagoonal environment. So higher current index is not favorable. Low current index is much favorable. So also the other parameters like compaction ratio and then preservation of carapace and other parameters. Then come to the next aspect, that is about the ecological aspects and statistical aspects. Whatever the baseline ecological data you obtain, the data is very much needed. Why? Because unless and otherwise you have got the ecological data that cannot be extrapolated to the older sediments. Older sediments, thereby you can deduce or infer the paleoecology. Paleo-environmental implications can be done only when you have the basic baseline ecological data. So the ecological data is very much needed, and it can be obtained through the live or dead forms. Then that data can be extrapolated to the fossil forms, and thereby you can discuss with the paleoecology or paleo-environment of the sedimentary basins. Then come to the next component of my lecture, that is tsunami sediments identification, paleo tsunami identification through microfossil distribution. We know that it is a Japanese term which indicates sea wave, and generally the tsunamis are generated through various factors. One is by the occurrence of the large, huge earthquakes in the oceanic environment. Say, for example, in the Turkey and Syria, you have got an earthquake of 7.8 intensity. Suppose if the same earthquake of intensity had it been occurred instead of land in water in the sea adjoining Mediterranean Sea or the Black Sea or Red Sea, where so it would have generated a tsunami. So like that, a huge earthquake when it takes place in the sea or ocean, it generates a tsunami. So also the other parameters like underwater volcanic eruptions, example Krakatoa, and the asteroid impacts like the Chicxulub impact, they also generate tsunamis and large landslides. They also large undersea landslides. So these are all some of the factors which will be taken into consideration for the generation of the tsunamis. Yeah, so this we have different plates, and oceanic plates are there, and the continental plates are there. Oceanic plates generally they have high density when compared to the continental or terrestrial plates. And this oceanic plate, this plate, when it goes down under this continental terrestrial plate, subduction takes place. Where it hits it, there it is rupture takes place. The energy is which is accumulated, it is released, and where it is released, that point we call it as focus or hypocenter, exactly on the top of the earth, where that is called as epicenter. So in the open oceanic environment, when an earthquake, huge earthquake takes place, the water above which it gets displaced and start moving. The movement of this water is known as tsunami. And in the open ocean, the tsunami, when it travels, it will have a huge wavelength, whereas wave height is very less. As it propagates towards the shore, the wavelength drastically reduces and wave height increases. Wave height increases. See, at a depth of about 4,000 meters, and the wavelength is 213 kilometers. And the tsunami, generally it propagates, it travels at a speed of about 700 to 800 kilometers per hour, at a speed of an aeroplane. At a speed of an aeroplane, it travels. So as it travels, see here you can see the depth and the velocity at which travels and the wavelength. Wavelength is drastically reducing. Okay. And then as it travels, as it propagates to the shore, and after reaching the shore, there is no further medium to travel this tsunami wave. So what will happen at the shallow depths? It starts scooping the sediments. It scoops the sediments and deposit on the nearby land and terrestrial areas. So like that, this particular marine sediments are being scooped and deposited, and those sediments are called tsunami sediments. If it is happened in the geological past, we call it as paleo tsunami sediments. How do you detect a tsunami? By sending a voice at these boys, they rest, they will have the BPRs, and they rest over the oceanic or sea bottom beds. And if any huge earthquake is going to happen it is being sensed or detected by these BPRs, and the signals are being sent to the satellites, and these satellites, they'll send the signals to the station. And there is an agency called Indian National Center for Ocean Information Services, INCOIS. It is located in Hyderabad only, and they are the nodal agencies which give information about the occurrence of tsunami in Bay of Bengal, Indian Ocean, and Arabian Sea. Let me come to some basic information which I would like. As far as the recent 26 December 2004, the earthquake, that tsunami is concerned, the Indian plate, it subducted the Burmese plate, and then a huge earthquake, mighty earthquake, more than 9 intensity earthquake on Richter scale has happened, and it generated a tsunami. And this is the thing, this is the phenomenon, subducting of the Indian plate, overriding the Burmese plate. So there, the tsunami has generated. And it has affected several countries, and India is also one of the country which has got affected. And as far as the movement of the tsunami is concerned, when a horizontal movement, we call it as inundation. Vertical movement, we call it as run-up. Run-up can be identified by identifying the watermarks, and inundation can be observed by the trailing of the organic debris and other things. To what distance vertically it has traveled, laterally it has traveled. And these are only some of the major tsunamis that have taken place in the Indian Ocean. These are all the statistics with regard to the Indian tsunamis that have taken place in the southeast coast of India. This I have already told you. This is the buoy which is being placed, and it gives signals. So early warning, it is being sent by the INCOIS. And of course, these are all some of the photographs. Of course, storm surge and tsunamis are there. And storm surge also, it brings a lot of marine sediments on the land. And tsunami also brings. And it is very difficult to differentiate a storm surge deposit from that of a tsunami deposits. Of course, there are, the geomorphological, sedimentary, paleontological features of these storm surge deposits, tsunami deposits will be more or less same. But some parameters are there through which we can slightly differentiate them, like this one. So this is a typical tsunami deposit where you have the abrupt lower contact, and the thickness is 5 to 20 centimeter, and there are some rip-up class. It is tsunami wave brings some boulder type of things, they are being deposited, and then you have the laminacets and mud cap. Whereas in case of storm surge deposits, you have the thick deposition of the sediments, marine sediment. 25 to 200 centimeter thick sediments are there, and the planar lamination and stratification is there, and it will have some foresets, troughs, and climbing ripples. Ripple marks will be there in the storms. So critical examination is very much needed in order to differentiate a storm surge deposit from that of a tsunami deposits. So yeah, this is an open pit where we can see how the layering is seen in a tsunami deposit. So we have undertaken a study immediately after 26 December 2004 tsunami that has occurred. We have carried out a field work along the coast of Tamil Nadu as well as Andaman area, and a couple of slides are there. After that, I'll wind up my lecture. I have time, madam. Hello?
Another 10 to 15 minutes, sir.
Oh, yeah.
Another 10 to 15 minutes, sir.
Certainly.
Please go ahead. Okay.
Yes. Yeah. So Tamil Nadu has got a coast of about 1,000 kilometers, and some of the areas are very vulnerable for the tsunami inundation and tsunami occurrences. They get affected, among which we have selected an area called Velangani, where the tsunami has attacked that December 2004 tsunami. And we have opened the trenches. Few trenches we have opened along the coast of Tamil Nadu, and these are all some of the locations which we have selected, and these are latitudes and some the depth of centimeters that we have opened. And this is the distance from the coast: 500 meters, 600 meters. So like that, away from the coast, we have gone and opened the trenches and pits. So this is one pit which is being opened near Velangani, and here we have observed two layers. One layer, the one layer, and these are the two layers where we have got the presence of microfossils, foraminifera and arthropoda. The rest of the layers, the rest of the sediments, they are devoid of forams and arthropods. So see, the top layer, 37, this particular layer, the bottom layer, both we have encountered the shallow marine arthropod forms, which indicate that this is a recent 2004 tsunami, and this one is a paleo tsunami deposits. In order to confirm when this has happened, when this particular paleo tsunami has happened, we need to go for the carbon dating, or otherwise OSL dating, optically simulated luminescence dating technique has to be employed, and then we will come to know about the age of this particular paleo tsunami occurrence. Then another pit we have opened near Kameshwaram, near Karaikal, and these pits are also giving some interesting results. So these are all the this particular 37 to 47, 39 centimeter to 43 centimeter. This is a recent 2004 tsunami, and the previous one, the older one, bottom one, is a paleo tsunami. So like that, we can, by opening up pits and trenches, by finding out the distribution of foraminifera and arthropoda. Generally, forams, they are all the shallow marine forms are occurring in these forms. So not only those microfaunal evidences, but certain sedimentological evidences also give you supportive evidences for the for identifying the paleo tsunamis. These are all the species which we have recorded arthropod forms. Similar studies we have carried out. From Andamans also. Immediately after December 26, 2004, we have carried out field work in the entire Andamans, starting from Port Blair to North Andaman, Diglipur and Mayabandar. Little Andaman we could not go, and this entire stretch we have made a field work. So there are about 349 islands, among which only 25 islands are inhabitants. Rest of the islands are not. People are not there. Then field work has been carried out in the month of May and June 2005, and then we have collected certain surface samples and also the core samples. Core samples and pits or trenches are being opened. This is the collection of the core sample, which is away from the 500 meters away from the coast in the mangrove area in Middle Andamans. And this is another field photograph collection of the conventional, core sample through the PVC pipes. And all these cores, which we have collected, pit samples, we have analyzed for micropaleontology, particularly for arthropods. And we have observed some fossils there. I'll show you now. And then this is an interesting field photograph where this is a newly constructed building. Here, the one which you are seeing is the first floor. The ground floor is totally subsided because of the earthquake, intensity of the earthquake, and liquefaction and other things. Land subsidence has taken place in a place called Ramapuram near Mayabandar, North Andaman. And there is a bridge which connects the Diglipur and Mayabandar, that is called as Kalighat Bridge, Kalighat Creek, Kalighat Bridge. To cross this from Diglipur to Mayabandar, this bridge is constructed, and it has got dislocated both vertically and laterally. So this type of displacement has taken place. And also the extensive damage to the mangroves in the Baratang area, Middle Andamans. Not only the land subsidence, at some places land upliftment has also taken place. The corals are seen when we were traveling from one island to the other island through boats. This is the damage to the vegetation in the South Andamans. And here, this is a human settlement area. Because of the land subsidence, what has happened, the saline water, the marine water has encroached into their houses. And these people are forced to evacuate their houses. It is a example for the land subsidence. And when we inquired with the local people, they say that the run-up is 7 meters up to this, the tsunami wave. So such is the intensity of the run-up, the high maximum. And not only that, in Middle Andamans, Baratang, you have got several mud volcanoes there. These mud volcanoes, they became active and they started oozing out the mud from these mud volcanoes. This is a damage to the house settlement in the Port Blair area. And this is another area interesting. These are all fully freshwater trees. Because of the land subsidence, what has happened, the saline water, the marine water has entered. Because of the presence of saline water, these freshwater plants, they died out. So this is an indication of the land subsidence. And finally, whatever the core samples, surface, pit samples or samples which you have collected, they are being analyzed for micropaleontology, particularly for the osteropods. And we have observed several species in that. These are all the species which we have recorded. All these species are supposed to live in the shallow marine environment at a depth of about 40 meter, 30 meter, 50 meter range. That is the range of their distribution. Marine inner shelf species. But these are all being reported in the on land, in the core sample and in the pit samples. That indicates that the tsunami has scooped the shallow marine sediments and got deposited on the continents or terrestrial areas. So the deposition of these sediments varies. At some places, if the topography is flat, up to 1 kilometer, 1.5 kilometer, these tsunami sediments are being dragged and deposited. But if the elevated area, if topography is elevated, then only the tsunami sediments are deposited or reached up to 500 meters only. So like that. And also, when you see the distribution of these micro fossils and the thickness of the deposition of the sediments, tsunami sediments, it varied from 20 to 25 centimeter in those areas. So this is the species which you have recorded from this. So with this, I just wind up and conclude my presentation. If you have any clarification or any doubts, you can ask. What I mean to say is osteropods are very, very vital. They can be used in the paleo-environmental studies, hydrocarbon potential of the sedimentary horizons, and also tsunami studies, high energy marine events, and also other various applications are also there. This is with regard to the fossils, whereas you have got mineralogy, you have got petrology, you have got economic geology, you have got engineering geology, you have got petroleum geology, coal geology, and oceanography, geological oceanography. Like that, several other disciplines are also there. So geology deals with all aspects of the earth, and which are either directly related to humankind or partially related to the humankind. So, like that, geology is a very, very important subject, basic science subject, and many of the students they can take up. And you also have to excel in your studies, and then you can get jobs in state government, central government jobs, and also the certain private companies. Also, you have got a lot of scope is there. And not only that, if you are interested in teaching, you can go for after the MSc, you can go for PhD, and you can select a teaching profession. Or otherwise, if you are really interested in research, you can go as a PDF to foreign countries and other things. For example, from Kadapa Yogi Vemana University Geology, Dr. Srinivasulu, he is presently working as a PDF in South Korea, and some students they are working. For example, Dr. Prasad, he is working in some tribal university in Vijayanagaram, like that. So what I mean to say is, it depends upon your zeal, depends upon your passion. If you are passionate enough, you can choose any of your teaching profession or research profession or any other kinds of profession. But among these basic sciences, geology is one important subject where you can excel yourself in your life. That's what I would like to say, inform you. With this, I conclude my presentation, and any kind of questions are welcome, and I'm happy to answer you.
Sir, thank you so much, sir. There are some questions in the chat box.
Yeah.
Could you see, sir, or shall I read out that one?
You please read out.
Yeah. Sir, this is from Surendranath Mopur. An elaborate presentation from Professor Hussain. Congratulations for his efforts. Before winding up this presentation, I expect the recent modern trends in astrocode or micropaleontological studies. Any signatures or linkages to global climatic changes? He was asking.
Okay. So, as I told you, any climatic change, for example, you have the warm climate and you have the cold climates, and you have got the other kind of arid, tropical, temperate climates are there. So, during these climatic changes, ever since the origin of the earth, you have got different variations in the climatic changes, and accordingly these the ostracod fossils are being deposited, or they are distributed. By studying the ostracod assemblage, we can find out what kind of climate it was, and whether it was a warm tropical climate or cold climate or arid semi-arid climate or something like that. And thereby, by studying in detail or extensive study from different parts of the country, different parts of the world, we can also give a recurrence interval of these climates also, past climates also, recurrence interval. So also the tsunami studies. By studying the paleo tsunami studies worldwide, we can also find out the recurrence interval of the tsunamis. So that way we can give an information with regard to the climatic changes.
Thank you, sir. I hope Surendranath, it's clear for you. There is another question from Gauri or something. You can unmute and ask. I don't know. She didn't ask the question. She has a doubt she is raising. But what's the doubt she is going to express? Anybody has any questions, please unmute yourselves and then ask the question. Or else you can chat in the chat box.
Sir, good morning, sir. I'm Professor Raghu Babu.
Good morning.
Sir, sir, it's a great and elaborate lecture, sir, on paleontology. Sir, almost 96 slides you have explained. Sir, I'm sorry I might have missed the link. I want to know, you said you have digged some trenches near the tsunami affected areas, sir. Hello?
Yeah.
Sir, in trenches you found some microorganisms. How it is related to the earthquakes, sir?
Yeah, see, we are opening the trenches away from the shore, away from the coast. So that is a terrestrial or continental environment only. But you are supposed to get your terrestrial or continental fossils only. But because the tsunami is bringing the sediments and depositing on the continental or terrestrial areas, and these tsunamis are of these microfossils are of shallow marine, and they are being occurring in these trenches and pits.
Okay, you want to say that that layer has been moved forward due to tsunami, yes. Sir? Is it?
Yes.
Thank you, sir. Thank you, sir. Thank you very much, sir.
Yeah.
Sir, there is one question from P. Jayalakshmi. Were there any supercontinents before Pangea supercontinent?
Yeah, it is there. Rodinia, Ur, and like that, several continents are there. 3 supercontinents were there, but their, the justification as far as Pangea is concerned, of course, all these continents, if you bring together, it fits and we will come to know about the existence of the Pangea in the geological past. But in the geological past, prior to Pangea, there were supercontinents over there, but the clear-cut evidences are not found. But some are few evidences were there. That is why we have scientists have observed, geoscientists have observed that existence of the supercontinents prior to Pangea. There were 3 supercontinents, I think so: Rodinia, Ur, and then another like that. Some 3 supercontinents were there.
Thank you, sir. I think another doubt, the same doubt has been raised by M. Gauri. I think they are clear by this time now. Any other questions? Okay, sir, could you please, Jaira, sir? Yes, maybe. I couldn't see.
So thank you so much for your comprehensive snapshot of the talk related to the age of the earth, to the tsunamis, a wide, broad spectrum of so many areas covering, giving emphasis to the tsunami. We have read your paper published in Current Science in relation to the tsunami and how astrocodes or micropaleontology helps in order to know some of the aspects of the tsunami. That has become a really popular paper, and we congratulate you and your team for having worked much on the tsunami, relating that to the micropaleontology as well. We thank you so much for sparing your time to be with us and to deliver exhaustive talk in order to benefit our participants and audience. Appreciate your time and talent and treasure so much. Thank you very much.
Thank you, Professor Jairaj Garu, and the convener, Professor Sunita Madam, and head of the department, Professor Raghubabu Garu. Thank you all for the opportunity given to me. And that's with regard to the fossils. And there are other talks are also there. Since we need to popularize paleontology and micropaleontology, that is why I have chosen this particular title. Okay, for the benefit of the young tender brains, young students, then they get attracted. So that is why I have given an overview of various job opportunities when they study geology. So a lot of job opportunities are there. That you have to give proper information to the students. Then only the students will be attracted. And of course, geology has to be introduced at a school level. If it is introduced at a school level, and the students, they will have a lot of awareness. In Japan, for example, at school level itself, they students are being trained when an earthquake comes, when a tsunami comes, how we have to face it. So that kind of training is given there. Whereas our students, they don't know about geology. What are the mineral deposits? What are the other engineering structures? What are the fossil fuels? And what is environment or climate change? And all these things, through geological studies, they are not much aware of it. So for which, we have to popularize our subject.
Thank you, sir, for your detailed and exhaustive presentation on astrocodes and their significance. Thank you very much, sir, for your valuable time for this lecture. And I hope we can popularize all these sciences, especially the geosciences, so that, and this has to be implemented at the school level so that people can know and they can tackle about themselves. So thank you so much, sir, for your elaborative lecture. There were so many comments that they are thanking you, and then compliments too. So thank you so much, sir, and hope you will continue your support for the coming generations. Thank you, sir.
Thank you,
So
sir.
it
Thank
is
you very much.
And may I ask you, sir, could you share your PPT if you have any, if you don't have any problem?
No. I will certainly share. No issues at all.
Oh, thank you so much.
And as such, your department is the vibrant and dynamic department as far as Andhra Pradesh is concerned now, with huge number of faculty strength.
Thank you, sir. Thank you, sir.
So
Thank you,
you
sir.
can contribute a lot and do more things. Okay. Wish you all the good luck, and then thanks for the opportunity given to me once again.
Thank you very much, sir.
Thank you, sir. And I think for the first technical session is over, and the second technical session for this workshop will start tomorrow at 10:30 a.m. The lecture will be about by Dr. A. Nallapreddy Garu regarding the recent developments in mineral exploration with special reference to organic fuels. This will be the topic by Dr. Nallapreddy Garu tomorrow. See you tomorrow at 10:30 a.m. Thank you so much. Thank you, all of you. Thank you, all the participants, for your good support and then good interest. Thank you.
Link same, Amma.
The link will be the same. You can
Yes,
join with the same link tomorrow. Yes, sir. Please, sir.
Yeah, as such, you are sitting on Kadapa Basin, where you have got huge deposits of barytes, second largest world deposits of barytes in Mangampeta.
Yes.
And
Yes, sir.
you do have Tumalapalli, this thing is there, atomic mineral deposits, and other deposits are also there. And really, it is nice to be with you today morning. Thank you.
Thank you, sir, with your busy schedule and all these your personal issues you are attending. Thank you so much, sir. Yes.
Thank you, sir.
This session will
Shall I leave? Shall I come? Shall I leave the meeting?
Namaste. How are you, sir?
Sudarshan Rao, sir, is you.
Myself,
Yeah, fine, sir, fine. Doing good. Yeah, fine.
How is Chennai, sir?
How is Chennai?
Chennai is good. Chennai is good, and recently we have got mild tremors.
When will you come to Kadapa, sir?
Whenever you arrange a meeting with me.
Definitely, sir. Why not, sir? Definitely invite next practical Dr. Raghu. Definitely invite, sir. Hope to invite.
You are the great hope for us, sir, for our department.
Yes. I'll be happy to visit Kadapa Yogi Vemana University and meet all my good friends.
Thank you very much, sir. Thank you, sir.
Dr. Gaud is on the line.
Dr. Gaud, sir, is on the line. He can speak few words.
Yeah, yeah.
Sir.
Yes.
Sir, namaste. Thank you very much.
Yeah, namaste, sir.
Thank you very much, sir.
Okay, sir. Namaste. Thank you very much. Nice seeing you all virtually.
Thank you very much, sir.
Okay.
Thank you.
Okay.
Sir, shall I leave, sir? Shall I call it a day?
Yeah, yes, sir. Thank you, sir.
Thank you, sir.
You can leave, sir.
Thank you. Bye.
Sir, please share your PPT.
ఇది ఇప్పుడు మనము అక్కడ ఓపెన్